This is the first of 5 video lectures about the MacroSim economic simulation model used in Economics 53. When I deliver these lectures in the classroom, they're typically divided into 2 lectures rather than 5. But because this year I'm presenting them as video lectures, I think it's a little easier to view these if they're shorter, so they're divided into 5. Now the slides you see here are represented on the class website. That PDF file consists of all 5 lectures in one slide. So let's get into this and not take too much time. The MacroSim models consist of MacroSim1, a loanable funds model that's an interim model, and MacroSim2. Mudd designed in the sense that I designed them in Python to be used with students who are familiar with Python. And these are not executables, they're still in Python mode, where you go into an IDE or an editor or Jupyter or something and play around with them. They're intended to demonstrate the complicated interactions that arise when multiple variables are changing simultaneously in an actual economy. Because, of course, in the graphical static, comparative statics models that we've been using, you really can't see that complex interaction, but you can see it in at least an elementary simulation model. Now, MacroSim1 is the oldest. It's an elementary national income determination model that's drawn from a vintage standard textbook treatment of national income determination. And MacroSim1 does not include a financial sector. Now, when I say it's a standard textbook treatment, I mean if you go back and look at textbooks from even the 60s, 70s, 80s, and 90s, even probably up to the current time, there was a model that's often called the Keynesian cross model in those textbooks. It was designed in the 1950s. It was very pedagogical, and so it stayed in the textbooks for a long time. MacroSim1 is the simulation of exactly that model. So if you're older, or if you've seen the model, or if you're using a textbook that has the model, in the Keynesian cross style model, and that makes it by far the most usable model. There's also another version of this that I don't actually offer in Econ 53 called MacroSim, which is designed primarily to estimate the size and impact of budget deficits. I'm probably going to link it from the site, but I'm not going to teach it in this class because there's only so much we can do in the time allotted. Now, the actual models are there for you to use. I don't require it in Econ 53. I've thought about doing that, but because we have some off-campus students and because we have some freshmen who may not yet be very familiar with Python, I've decided to not have you use the models as sort of a homework requirement. So you can get through all of this lecture without ever downloading the models or looking at them, but I do make them available to you, and they are on the class website for the course reading material that's shown right here, the course content page for 2020. If that's the year you're looking at this. And down at the bottom, you can see we have MacroSim1, which is a zip file, loanable funds, MacroSim2, and the MS2 OMO is the MacroSim model that I was talking about that we don't actually use in this class, or maybe I actually do toward the end of the class. I don't even remember. And then, in case you just want to have all of them, then all of them are also loaded into a zip file where they're all there. Now again, to run this, you have to pull it up in an IDE or in Jupyter or something like that, and take the default, run that, and then override the values to see what kind of results you get. And they are very interesting to do. Again, it's not required, but if you have a time to take a look at it, even after the class has ended, take a look at it and see what you think about these models. Okay, MacroSim1, as I say, replicates the standard Keynesian cross model that appears in most introductory macroeconomics textbooks. Maybe not anymore. I'm not sure what the state of the art is there because I don't use textbooks. As such, it does not include a financial sector, which is a serious limitation. Although it allows for the existence of a budget deficit, it does not concern itself with how the deficit is financed. So any implications that are negative in the model or in a model that might arise because you are borrowing a large amount of money does not show up in this model, and that's one of its primary deficiencies. It treats investment as purely autonomous, which means it's determined from outside of the model. It's unaffected by interest rates. There are no interest rates in the model. And so the user of the model arbitrarily chooses the level of investment. And one of the primary purposes of this model is to explain the concept of the multiplier, which it does reasonably well. Now let's take a look at the variables in the model. You may have to refer back to this page if you're going to follow this very closely. Y refers to national income or GDP, because this is a sort of Say's assumption at work here. They're both the same in this model. This is a model also that has no external sector, so there's no exports or imports. C refers to consumption, and you know this is the same application as found in the NIPE accounts with the same definition. B will be the consumption coefficient, which in the tradition was given the ridiculous phrase, the marginal propensity to consume, because that's what Keynes actually called this in his 1936 book. And so that sort of hangs in the literature, although I think by now it's largely gone. The consumption coefficient, and we'll see how it works when we see the equations in the next slide. T is the income tax rate, like 20% as a percentage of GDP. Disposable income is income for consumers after taxes. I is for investment, which, as we said, is autonomous in the model, so is given from the outside. Government spending is also autonomous as a policy variable, given from the outside. Savings is a residual in this, as we'll see when we look at the equation. And the budget deficit is, as defined, the spread between what the government takes in revenue and what it spends. And M will stand for the concept of the multiplier, which we'll look at here in just a minute. So when we take a look at the mathematical structure of the model, this is what it looks like. And this is, as I say, really identical to the Keynesian cross model that you used to find in textbooks for like 4 decades or so. So at the top we have the standard identity. That aggregate demand consists of the sum of all categories of aggregate demand: consumption, investment, and government spending. No net exports again, because this is a closed economy by assumption. And this is the same, of course, identity that's found in the NIPE accounts, if you remember back to our discussion of those. The consumption function is linear, and it consists of autonomous consumption, A, which is not a dependent of your income, and your income and the disposable income you have after taxes, and that is multiplied times the consumption coefficient, which will have a value like 0.75 or 0.8 or 0.9 or something like that. Again, that used to be called the marginal propensity to consume. Then by definition, disposable income is national income after taxes has been taken away, so that's equal to Y minus TY. The deficit is equal to the spread between government spending and tax receipts, and so that's equal to government minus the tax rate times Y. Savings is an identity equal to the sum of investment plus the budget deficit. So this introduces a new concept. It's assumed that all investment is financed by savings. In the loanable funds model, that would mean that all investment is financed by borrowing. And that's kind of a common assumption in these elementary economic models. And then finally, at the very bottom, we get the calculation for the multiplier, which is the inverse of 1 minus the consumption coefficient itself times 1 minus the tax rate. And that's just derived mathematically from the model. And we'll look at an example of that next, so you can understand that better. So equation 6 is the multiplier. Now this is the derivation of the multiplier, and this is why the Keynesian cross model was largely developed. It introduces the concept that if you increase a source of autonomous spending in an economy, such as government spending or investment, if that's regarded as autonomous, the final effect that it has upon income determination will be a multiple of the original stimulus. And that is true in an economy. So as it says here, the traditional textbook introduced the multiplier. An increase in autonomous spending, like government spending, would have a leveraged impact upon the level of national income. So I won't go through these equations here. You can come back and look at this. But we start out with the identity expressed as a difference equation, where X is either the change in I or the change in D. In other words, the change in either investment or government spending. Those are one of the two sources of stimuli in this model. And then we just continue to reduce that down by substitution through equation 2, substitution more through equation 3, the same for equation 4, the same for equation 5. I'm not going to go through the elementary algebra here. You can do that if you're not convinced. And we finally get down to the bottom where we say the change in national income is going to be equal to some multiple of the change in autonomous spending, mx, and that multiple, the multiplier, is as we described on the previous page. It just falls out algebraically in equation 5 is equal to the inverse of 1 minus b, 1 minus the consumption coefficient weighted by 1 minus the tax rate. So again, the tax rate t is going to have a value like 0.2, and the consumption coefficient is going to have a value like 0.7, 0.8, or 0.9. Okay, so once we have this set up, we'll be able to run a few simulations. Now, let's see a little bit more, though, about the multiplier, because that is the one valuable thing that arises from this model. If the consumption coefficient is 0.8 and the income tax rate is 0.25, then the multiplier is going to be equal to 2.50. In the context of this model, that means that if autonomous government spending or investment, either one, is increased by $1, then national income will rise by 2.5 times that, or $2.50 in this example. This reflects the secondary and later spending that arises from an initial stimulus. So in other words, if you earn additional income, you spend it, and another party therefore earns additional income, and they spend it, and so forth, until, because of the tax rate and the fact that some is saved, the effect finally dies out. And the concept of the multiplier is a little less relevant at the national level. It's regarded as extremely relevant at the local or state level. And one of the sciences of economics is to estimate local multipliers, let's say for the Ontario area of California, where one might say that if a new business comes into the area, into that area of San Bernardino County, and the multiplier is like 2.4, that means if that business generates $1 million in payroll, that it will stimulate the economy by 2.4 times that, or $2.4 million annually. And that is regarded as a valid concept. So this is probably your first exposure to it. Now, let's take a look at the default assumptions. Again, as we're pointing out, there's no imports or exports. So we're going to assume, of course, these default assumptions are set up by me, so they lead to clean results and are easy to follow. There's no connection to these assumptions and any actual economy, except that the coefficients are more or less in the ballpark. So we're going to say that this may be in millions of dollars or billions of dollars, but we'll just say $2,800 is our stable state. It's going to turn out that the level of consumption in the solution to this is $1,780. Again, perhaps times a million, perhaps times a billion. And when you look at this and you see assumed in blue or solution in black, that means that you're assuming the values that are blue and the values that are black, such as GDP or national income, Y, is solved by the model. That's the solution that's kicked out by the model. That's not an assumption you're making. So the actual assumptions consist of the consumption coefficient, which is 0.75. Actually, this slide is slightly wrong. It does not show the tax rate in blue, and it should. There's always mistakes in my slide. If I review them 1,000 times, there will be a mistake in it somewhere. So the tax rate is also assumed, and that should be blue, sorry. Investment is assumed because it's autonomous at 420. Government spending is assumed because it's autonomous at 600. So although government spending is assumed, government receipts are not. The assumption about receipts is the tax rate, 0.20. It'll end up, I should say, that the savings in this economy will be 460, and given all of this combined, the budget deficit will be positive at 40. And the multiplier, as we've already calculated with these assumptions, comes to 2.50. So the actual model itself involves starting with these default assumptions, and again, what is shown in black, except for the tax rate, that's a mistake, is actually the solution. Now we'll take a glance at the model here that's running the default. You can see here the way I'm doing this is running it in an IDE, and that's either Notepad++ or Sublime Text. I forgot what I'm running this in. I haven't run it in a while. And so you can see the assumptions there at the top on the dark blue, and that of course is inside the IDE. A is equal to 100, that's the intercept value of consumption. The consumption coefficient is 0.75, investment is 420, the tax rate is 0.20, and government spending is 600. Then the equations are down below, represented as I had them represented on the previous page. And of course we're running this inside a terminal, so we copy out of the terminal and we see that this confirms what we had on the previous page. The multiplier is 2.5, GDP comes out to 2,800, disposable income after taxes comes out to 2240, taxes collected equals 650, and the budget deficit, I should be pointing at these as I do this, I guess, 650, the budget deficit is 40, and savings, which in this case is a residual, is 460. And these down here are just logic checks to make sure the model's running correctly. So that is it for our introduction to MacroSim 1. That's the end of the first video. In the second video, we're going to shock this model to see what impact changing autonomous spending has on it. We're going to ask some questions and see, for example, the multiplier works. For the moment, we're done.